All right, we're on the last video for today, and now we're going to use samples to make predictions. And this is very commonly used in the real world. All right, and it is a note card. This is note card 262. So, the table below shows the results of tossing a coin 100 times. So, someone sat there and tossed a coin, and they got heads up 58 times and tails up 42 times. Now, in theory, we would expect heads up to be 50 times and tails up to be 50 times. So, theoretically, in part A, how many heads would you expect to occur in 300 tosses? Now, this is just data from 100 times. So let's see. We would expect, not using this data, okay, we would expect it to happen half the time. And we could do 1/2 or 0.5, because that would be what we would think. Don't use the percentage. Use either the decimal or the fraction, equal to X amount of times over 300, which is 150. Now, some of you just like, I just know it'd be half. Okay, well, good. 1/2 times 300 is 150. But this is just work for those of you that need that. You just cross multiply, you get 300 equals 2x divided by 2. But guys, listen, if you know the probability of getting a heads up is 50% and you're going to toss it 300 times, you would expect it to be heads up half the time. So 50%, 0.5, 1/2 of 300, which is 150. But based on this experiment, how many heads would you expect to occur in 300 tosses? So again, part A is in theory, but based on this experiment, this one we actually can't just go, oh, it would be 150. We would do 58 out of the 100 times is what happened to get the heads up, equals however many, we don't know, x over 300 tosses. And you cross multiply, you get 100x equals 17,400, divide both sides by 100, and you would expect that to happen 174 times based on this experimental data, okay? So in theory, it'd be 150 times, but based on this experiment, it'd be 174 times. So pause me and finish up note card 262. All right, now we're going to move on to note card 263, the last note card of the lesson. And here's a table showing an experiment, okay? Results of randomly selecting a letter from the word rhombus 80 times. It's randomly selecting a letter from that 80 times. So how many times was this R selected? Was 15, H 10, so on, so on, so on. But they selected a letter 80 times. They could have used a random number generator. They could have written those letters on a little piece of paper, put them in a hat, and just drew it 80 times and recorded the data. Okay? So ignore this for a minute. So in theory, if a letter is randomly selected 500 times, how many vowels would you expect? Vowels, A-E-I-O-U. So how many vowels are there? There's O and U. So 6 plus 18. How many is that? Wait, no. I'm not looking at that. I'm sorry. In rhombus, look right here, because we're not looking at the experiment yet. We're doing theoretically. All right, so there's an O and a U. There's only 2 vowels out of 1, 2, 3, 4, 5, 6, 7 letters. So 2 out of 7 vowels equals, you don't know how many out of 500. You cross multiply, 7x equals 1,000. You divide by 7, and that'll be a decimal, but it's approximately 143 times that you could select a vowel, okay? If you're randomly selecting 500 times, about 143 of those times, you would get either an O or a U. Now, based on the experiment, if a letter is randomly selected 500 times, how many vowels would you expect? So over here, 6 and 18, that is 24 out of the 80 times equals, I don't know, out of 500, you cross multiply, 80x equals 12,000, divide by 80, it'd be 150 times. So again, we have our in theory and our experimental, and these were making predictions. So go ahead and pause me and finish up note card 263.